Welcome to the Glassworking shop. Well, the pieces have been resized and cut into chips, and now it's time to assemble them using the Chipstack assembly fixture. So I'm going to go into a little bit of detail here showing how the process is done, and then put it in the kiln and come back and fuse it together. So the Chipstack assembly fixture is, let me turn the guy over here. It starts out with a steel base, and I've milled away a bunch of holes, leaving a support web. And the idea here is to keep the steel from sucking all the heat out of the graphite. And of course, like so many things in my designs, it's just based on intuition, not engineering analysis. I have no idea if it really works, but hey, it seemed like a good idea at the time. Got a couple of spacer bars attached here so that when the piece is sitting on a surface, I can use this fork tool that I made to reach in and lift it up. In the past, when I've made assembly fixtures, and let me get this one out over here. This assembly fixture has metal plates and metal screws, and I find that when a metal screw goes into a metal plate and then gets heated repeatedly in the kiln, sometimes this one's actually fairly easy to move, but I've had them in the past where they start seizing up and get difficult to move. So an attempt to make this a little easier to adjust, the blocks here are made of graphite and the screws are stainless. And since obviously I can't touch a hot screw with fingers, I also went out to the toolbox and found a socket and a short extension that allow me to adjust these guys once they're hot. Now each one of the screws has a hole in the end strategically placed so that a 1/4-inch graphite rod sits perfectly on the surface, allowing adjustment and application of force with a single rod. I've also discovered that the first idea was to use these graphite rods, but then later I discovered that in some cases, a flat piece of graphite that just sits up against the screw and doesn't actually go into the hole, sometimes a flat piece of graphite seems to work a little better. So once again, the design is ongoing. It's an evolutionary, incremental evolutionary process that hopefully is getting better over time. So the chips up here have been cut to 0.3, 300,000ths, 3/10 of an inch, and stacked here in order that they were cut. So this is the order of chips the way it was originally made in the pull. I don't yet have the skill, and somehow I suspect that even the experts don't have the skill to make a murrine piece that is absolutely uniform at every point. I think even the experts may have a little bit of non-uniformity, although the people with more skill do it better, obviously. At my current skill level, the pieces are somewhat non-uniform. The pattern is different at this end than it is at this end. And so in an attempt to make the result seem to fit a little better, I use a technique borrowed from woodworking, which is called book matching. And that's commonly used in the world of woodworking and veneering, where you take a piece of wood and then slice it and then open it up like a book so the grain matches. commonly used, for example, on guitar backs to try to get a guitar back out of a single piece of wood is difficult. Usually they require two, so they take a piece and cut it and then spread it out. So what I'm doing here, since it's somewhat difficult, somewhat tricky to keep this under control because the pieces aren't marked. And if I got them randomized, I'd never figure out which one was which. And if I start trying to assemble them without some sort of a systematic plan, it's real easy to get confused really fast. So I cut them, and then as they come off the saw, they're stacked. So I know that that stack is still in order. Then I fairly carefully just adjust them out like this, little bit by little bit. And then once I have that, then I know it's safe to do this. And so I have now preserved the order, and then I can put them down like that and begin to assemble in order. So there we have it. And now I'm gonna start getting the and little bit by little bit, by somewhat careful adjustment, I get the whole thing to line up. Then looks like I'm going to have to pull my little center guy. I have a little piece of murrine that I use for the center, but since these pieces were resized, it looks like the hole in the center is a little smaller than my center piece, and so I'm going to have to pull another one, and I'm going to do that off camera. I think I've shown pretty much what I need to show on how the assembly fixture works and on how the chip stack alignment works, and a little bit of an idea of how this all works when it goes together. So I'm going to turn the camera off and get one prepared, put it in the kiln, heat it up, and then when I come back I'll be fusing it together. So see you later. Okay, the pieces have been in the kiln for a while, and I think we're ready to go. I got my very dangerous pilot light here that seems rather inconsistent going, ready for the hand torch. Hope I don't set myself on fire with that thing. Taking the assembly out with the fork, and now I'm putting it on a little fixture here that elevates it off the table. Don't want to put it right on my bench, even though my bench is made of fire-resistant stuff, I still don't want to risk getting the heat directly on the tile because it might crack. Here's a tool I made. Let me show you over here on the camera. This is a paddle that has a strengthening piece, so I can apply force down like this and not break the graphite. So that's one tool. Then I've got a regular paddle and another kind of custom-made little tool here for pressing the edges together. So what I do here is just use the hand torch and gently heat the surface to fuse it together. And yes, it looks like I have some problems in this piece. Like I said in previous videos, a lot of this process is still a mystery. I'll get really good results one time, and then somewhat less good results next time. And it appears that I have, even though I used pretty much the exact same procedure this time that I used in previous times, it looks like I have some problems here. But like I said before, I show my mistakes. I show my confusion. I show my mysteries. I show the, what the fuck? It shouldn't be happening. It's all R&D. I've never had one of these crack in the kiln before. But still, even with the problems, I'm able to adequately demonstrate the fixture and the technique. So the point here, I don't fully fuse the piece in this fixture. I just get it stuck together well enough that it can be finished on my other piece of graphite. This is just a preliminary holding fixture just to get everything somewhat stuck together. As I look at the piece, I'm seeing some air bubbles. And it's interesting that the last one that I did off camera was a lot better. And now it seems like as soon as I turn the camera on, attempting as hard as I can, trying with all the skill I can to do it exactly the same as it was before, and then there's my pilot light. Oh, and it's so hot and it's almost impossible to adjust when hot. So I'm going to remove this, loosen the screws, take my, and I know this piece is cold, so it's safe to grab. I'm going to take this piece, the graphite with the backstop, and preheat it so I don't shock my assembly too horribly much. And now, using the backstop, I'm going to complete the fusing operation. I think out of all of the steps that I've performed here, the weakest and most problematic step has got to be the assembly of the components. I think the components themselves are actually coming out quite nicely, but the assembly step has, the hot assembly step has quite a lot of room for improvement, and as soon as we get back to more normal times, I think I'm gonna try to arrange for lessons with people who understand hot assembly a little bit better, because I think I'm actually very close to having this kind of under control, but still I'm not going to abandon this piece and throw it away, because I do believe I can recover something out of it. It may not be my best piece ever, but I do believe that I'll end up with something useful. The backstop allows me to apply force with the paddle in this direction, which helps to shape the object. So that is starting to look like it's getting moderately well fused together. I'm seeing air bubbles and sparkles and all sorts of other things that I don't like, but hey, I'm just going to keep going. It's all an adventure. And of course, I've said this before as I demonstrate the use of the reinforced pressing unit here, the pressing paddle. I'm not claiming to be an expert when I make these videos. This is not the master giving a class. This is my adventure. This is the path I'm on to learn this wonderful art form and demonstrate my inventions, some of which may not be ready, some of which may be early prototypes that barely work. Some of them may be preliminary ideas that end up being later dismissed as, oh well, seemed good at the time. I like making videos. I like sharing what's going on. And I think that there are people who are interested in the insight of just seeing, well, how is R&D done? How are things perfected? And of course, that's not to say anything against those masters who have it down perfectly and choose to make videos showing how it's done the proper way. I love that. I love watching the experts. But I think it's also kind of fun to get like a little window to peek into the R&D lab and see what's going on. That's why I titled this YouTube playlist My Glassworking Adventure. So little bit by little bit, I'm just closing up gaps, flattening a little, trying to keep the piece under control. Getting the edges under control is difficult. Actually, this entire process is difficult, and I think there's a lot of room for evolution and improvement. I like the idea. In general, I like the idea. When my teachers first taught me chipstacking, every one of them, basically assembled the thing in midair. They'd punty up one piece, either on a solid rod or on a hollow tube, and then using tweezers and either a hand torch or a bench torch. Actually, no, with the punty method, you have to use a bench torch. And then using tweezers, fused the pieces together basically in midair. And every time I tried it, I made a hot mess. That seemed like a skill that was rather difficult to learn. And of course, when I see other glassworkers, particularly the soft glass traditional Murano style glassworkers, they lay out their chips on a pastorelli, put it in the glory hole to preheat, and then stick a bubble to it. And of course, other boro workers that I work with do a variant of this technique. So I thought, why not just assemble it in a fixture? And of course, heat the top and make it flow and make it fuse, the graphite is sucking out all my heat. And in my evolution of this, and hey, I forgot to turn on my ventilation. Hope it doesn't kill me. In my evolution of this, I've tried a variety of different substrates. When I first did it, I tried a mild steel substrate. And of course, steel is an excellent conductor of heat. And so my problem of sucking heat out of the part was much, much greater. And the mild steel ended up getting a really nasty kind of a mill scale buildup on it that had to be cleaned before every use. So my next experiment was to switch to stainless, which got rid of one problem but didn't do a thing for the other problem. It was still metal, still sucked all the heat out of the piece. So then I tried a fire brick, and it cracked. Tried a floor tile, it cracked. Went to McMaster Carr, ordered an astoundingly expensive piece of what they claim was high temperature ceramic material. It cracked. And then I thought, well, what's left? Graphite. So I'm currently using a piece of 1/2-inch graphite and still occasionally looking through the industrial world, the materials world, to see if, well, is there a different high temperature material that may be appropriate for this that doesn't suck as much heat out? I've also thought about machining a pattern into the bottom of the graphite to make it thinner. Of course, if I do that, I lose the strength, and then I push down on it with my reinforced pusher paddle and I break it. So I've been thinking of various different metallic webs and graphite skins and all kinds of ideas. And meanwhile, I'm sure that some people who have had great success doing it the traditional way are probably thinking, dude, why don't you just practice? Learn it the way it's always been done. All you need is practice, dude. Stop trying to invent, just learn from the masters. And you know, they may be right. I'm not completely discounting that possibility, but hey, I'm an inventor. Sometimes I invent things even when it's stupid to invent things. Sometimes I reinvent the wheel when I could go buy a perfectly nice wheel. Sometimes I win. Sometimes I invent things that really are useful. Sometimes I just waste my time. Sometimes I discover that a thing that I spent so long working on and trying to invent it, and then I look in a catalog and find out, oh yeah, it's already been done and they did it better. So it looks like an object will be produced. This will not be a failure. And it's entirely possible that if I didn't tell anybody about the air bubbles in the crack that I closed up, that maybe somebody looking at the finished piece wouldn't even know it had a problem. So, but then again, that's also, it's the way R&D engineers look at things. We always focus on the problems and try to imagine, okay, what went wrong? How do we fix that next time? And of course, as long as I'm ranting about philosophy, there's another comment that I can make that I learned early on in my engineering career, where a very experienced engineer told me, the old engineer knows exactly why all the new ideas won't work. The old experienced engineer can tell you exactly why your idea is stupid and it won't work, and why you shouldn't even bother. The young engineer doesn't know any of this, and he goes ahead and tries anyway. And in most cases, in almost every case, the old engineer is right. The idea is stupid, it doesn't work. The young engineer wastes his time, learns a bit, learns to respect the old engineer, and gets on with his career. Except for sometimes, when they invent something that changes the world. Of course, none of my inventions are ever going to change the world, but who knows? You know? You don't have to change the world to be useful. So little bit by little bit, I'm attempting to fuse it together, close up the air bubbles. It's really unfortunate that the one that I chose to video is probably the worst one yet as far as trapped air. It really just drives home the point that I really need to work on air control. Because everything else I'm doing kind of seems to be working more or less. Try heating that edge off the surface. Okay, well, it's approaching the point where I'm going to say, you know, that's about as good as I'm going to get it. I don't need to get the surface absolutely flat because it will be lapped, and of course all of this paddle manipulation that I'm doing kind of smears the pattern, so even if I could get it perfect with the paddle, it still wouldn't be usable as it comes out of the kiln. So one more heat. And that concludes the glassworking. Into the kiln it goes. So that concludes the video, and you know, thank you for watching, and it's nice to see that somebody is interested in watching my R&D and watching me fumble and stumble as I make my way on the path through this magnificent adventure of glasswork and inventing and the life of a creative person. So that's it. It's been fun.